Monitoring procedures, vegetation measurements, richness, part of the Rocky Mountain Field Institute Citizen Science Training. As a citizen scientist, your schedule will be to work once a month, once before RMFI volunteer work begins on a trail and once per month afterwards. We will start our work in Garden of the Gods, and all the equipment you'll need will be provided to you. After watching this video, you should be able to identify native and non-native plant species in our project areas and collect vegetation data, including cover and richness, using Quadrat method. Our data collection objective discussed today is to measure vegetative cover and richness on social trails. To reach this objective, we need to understand what a social trail is. Social trails are unplanned trails that occur adjacent to existing trails because trail conditions are poor, between two landscape features of interest, or in areas close to protect sensitive landscapes and/or wildlife habitat. Another term we'll use is richness. Richness is the number of different species in a given area. Some knowledge that should already be in our toolbox. A transect is a line along which measurements are taken. Transects can be random or systematic. We will use two kinds of transects. We'll look at the longitudinal measurement of the restored trail profile and the longitudinal measurement of the social trail profiles. How will we know when we have sampled enough? We will collect richness data along transects that are sections of social trails where seeds were spread to close the trail. We're only interested in the effects of RMFI's restoration work, so this limits our transect parameters. For example, here in this picture, we have a social trail, and our transect is going to be just as long as that social trail. But with regard to how much we need to sample, i.e. how many quadrats we need to use, that is up for interpretation. We need to start measuring to understand this a little bit more. So we're going to start by collecting richness data along transects every 10 or 30 feet, depending on the condition and situation. If this seems like redundant sampling or not enough sampling, we'll modify these numbers. So let's think about richness in more depth. Richness is the number of different species in a given area. Part of our measurements include richness in closed social trails to identify what restoration seeds are germinating when RMFI restoration crews spread them, and to see if the cover is increasing overall, an indication that we have successfully diverted the recreational traffic. For our purposes, the area in question is the area where RMFI restoration crews spread seeds in a closed social trail. The defined area could be an ecosystem, a region, a landscape of management, and other contexts. So let's take a look at this picture. This was a trail that was closed in 2015. And if you look at the picture, you might not even know where the trail was before we closed it. But I'll show you right here. All right, notice that we put in some rocks. These rocks, helped us to close the area more, make it less palatable for people to walk through. You can see that we also maybe did some transplanting here as an example. But the most of the vegetation in this former social trail corridor rose up from seeds that we spread. And so we want to know which seeds are germinating and which are succeeding in this context, because the seeds are expensive. And we want to have the greatest success in the shortest amount of time. The faster we can basically make the trail disappear on the landscape, the faster we're going to stop the recreational impact. So richness is the number of different species in a given area. To measure richness, you simply count how many different species you see in the transect established in a social trail. Knowing the species is one kind of information. Knowing that species are different from each other is another kind of information. Ideally, we would record the actual species present, but if unknown, the number of different species is still valuable information to obtain. Writing descriptive notes will help you figure out what the species was later. Collect a sample of a grass inflorescence, for example, to help identify the grass later. Take a picture of any flowers. We don't want to be removing any flowers because their abundance is very low, and removing any parts of these plants could jeopardize their survival. So richness and cover can be measured together. So to estimate cover per species within a quadrat, the first thing you need to do is find the richness. The second thing is to estimate cover for each species, then add them together. So this picture should look familiar to you because we looked at it in the vegetative cover video, if you've already watched that. So in this, we have about 3 species, okay? Right here is species 1. This is blue grama grass. It's kind of a taller grass. It has a flag shape. You can look in the flora video for that. Here we have species 2, which is the yucca. And then here we have species 3, which is buffalo grass. Very similar to the blue grama in its seed head, but the buffalo grass is really very low to the ground and kind of curly. Okay, so what's the richness here? Richness equals 3. Okay, now we need to estimate cover for each species. So we want to see in how many squares does each species appear. Then you add all of those values up. So realize that there can be more than one species in a square, and there can be a plant that's low to the ground and a medium height plant. And one thing we're not even thinking about right now is there can be tree canopy, which is very difficult to estimate with a quadrat, of course, but other methods are used for that. So in conclusion, collecting richness data is very challenging. It is the most difficult part of this citizen science effort. And in fact, we have no plots to collect this information in right now. We will get there, but richness is a concept that will be the last piece of knowledge that is really solidified in your mind. Don't let this video freak you out. The rest of the Citizen Science Initiative is much more straightforward. Thank you. To get more information, here's an online textbook about field methods in vegetation science.